And then I'll do this anyway, but I don't want to, you know? Okay. Okay. Hello. We did this in class. And so this version, like the notes, I might be missing something because this is like a different set. But I want to talk about why I was getting two different numbers because I know why. Now I know. I didn't then. So over here, I'm just going to add that, so whatever significance level you're looking at, if your chi-square value that you calculate is below the critical value, like it's less than, you accept it, the null hypothesis. Oh dear. And then whatever you have calculated is greater than the critical value, you would reject. So again, this is like for sure in your notes. Like these four things I'm gonna write. Okay, so using p-value. So if your p-value, and this is next to the coffee page, like it's in your notes, like there's a little part from the book, FYI. So your p-value is greater than your significance level, and so this would be like 5%. You would accept. So see how they're different. Why would they be the same? You know, p-value is less than, you're gonna reject. And then there was like a comment about like, well, wasn't it bigger than, like, you have to pay attention to which test, like which value you're using. And remember, this is for 5%. Sometimes it's 1% or 10%. It just depends. Okay, so that. We are using the chi-square, like this one. And so I'm going to move it over here. So we're given a significance level for this test is 11.07, specifically for this example, like specific to this. And so when you enter this all in, you get, I promise you. So again, I'm going to rate it. So this is 5%. You get 22.24. So let's just round that to 22.2. Okay. And the degrees of freedom are 5 because it's the number of things minus 1 for this type of test. Okay, so with that being said, because, so let's look over here, right? So 22.2 is greater than our significance value. So my chi-square is greater than, so it's going to be this second inequality. So therefore, I'm going to do this little triangle dots, therefore. I don't know if you all know that. Therefore. Some math proof stuff. We reject the null hypothesis. So I guess this is not uniform. Okay, it's fine. Everything's fine. So it also says find p, just like for good measure. Again, your calculator is gonna give you that. You might get, because what is this? 1, 2, 3, 4. You might get 4.7135 e to the negative 4. Yeah, so remember that we can't write this on our exam, nor should we write it on a math paper, please. Thank you. So decimal form. So p equals 0.00047. Let's do, have those be 3 sig figs, so that would be 7171. Yeah, because 1, 2, 3, 4 decimal point. Okay, so let's think about that. This p-value is really small. So same thing, like this p-value also confirms that we should reject our null hypothesis. So they both should be in accordance. Yeah. So How did we get 6.83? Great question. How did, it was me, Moose, get chi-squared equals 6.83? Well, I entered them as matrices, and I didn't have to do that. Entered as matrices, and didn't need to do that. Didn't need to do that. Yeah, my bad. So it's so funny because on my paper too, I have like the steps, like I have list 1, list 2. So I don't know why I was doing a matrix, but that's that. So in conclusion for this, again, like if for some reason you came up with this, right, then you would accept. And so just be mindful of that. I made that mistake. I don't know why I was using matrices. So for this, we are going to reject. So we collectively reject the null hypothesis. So, oops, I forgot an I. Die does not satisfy a uniform distribution. And they're talking about this data up here. This one is uniform. This one is not. Okay, and then I wrote this in class, but I'll just add it here. I'll try to write smaller. It tells us how close, like what's the point? How close is the observed? I guess that's plural. Hold on, I'm having like a crisis. Hold on. How close are the observed and expected data? Okay. All right. Calm down, everyone. Okay, so that mystery has been solved. I don't feel great about that. Never enjoy making an error, especially with matrices. Okay, bye.